video, we're going to look at solving some more complex radical equations and looking at the extraneous solutions and taking what we learned in the last couple of examples and kind of putting it all together. So we have a radical function, and this does not look like a traditional radical function, but it's going to be x squared plus 5x plus 5 raised to the power of 5 divided by 2, and this is equal to 1. And like this one looks like, oh my gosh, this is going to be crazy because we're going to have to multiply this trinomial 5 times, and it's just going to be so much. But here's the thing, it's not as complex as it actually looks. There's a lot of little pieces to it that make it look a lot more complex than what it is. But in reality, remember when I would take, let's say like if I did the square root of x equals, I don't know, I'm just going to choose 1. The square root of x can actually be written as x to the 1/2 equal to 1. And now I just need to think, what do I have to multiply to 1/2 to get 1? And when you do that, you have to multiply the reciprocal, 2 over 1. And what I do to one side, I have to do to the other. No, I don't know why I wrote 2. So 2 over 1. And so now on this side, I have x to the power of 1 equals 1 squared. That's essentially what you're doing here when you square both sides. You are actually raising it to the reciprocal of this radical. So I'm going to do the same thing here. I'm going to look at this 5/2, and I'm going to just raise this whole thing or multiply it to the power of 2/5, the reciprocal. And what I do to the one side, I must do to the other. Okay, so what happens here is the exponential property takes care of this guy right here. This guy right here becomes 1. So now we have x squared plus 5x plus 5 to the power of 1 equals 1 to the 2/5 power. Well, I'm glad they picked 1 because 1 to any power, even if it's a radical power, is going to be 1. So we now have x squared plus 5x plus 5 equals 1. We have a quadratic, so with a quadratic, we do need to move that 1 over and make this equal to 0, so subtract 1 from both sides. So now we have x squared plus 5x minus 4 equals 0. And now we could solve, or we could factor, or whatever method you want to use to get your solution of this. I'm going to do factored form just because it's not that bad. See, 1 and 4, so this is plus 1. Oh, this is a plus 4. I didn't follow the plus down. That's why I was a little confused. I was like, that's a negative 4, but it works out. 4 times 1 is 4. 4 plus 1 is 5. So my solutions are x equals 4 and negative 1. Put the negative in there. The next thing to do is now check for extraneous solutions. Let me clean up this side right here. We don't need this extra space, and I actually do need this extra space to write in. So the first thing I'm going to test is x equals negative 4. Into the original solution, I'm going to substitute negative 4 into it. Negative 4 squared. Make sure the parentheses go around the negative 4 because even that negative is getting squared. Plus 5 times negative 4 plus 5 to the 5/2 equals 1. Well, negative 4 squared is 16 minus, that's 20, plus 5 to the 5/2. Technically what we should get is 1 because we have to get a solution of 1. So let's see if we get that. 16 minus 20 is negative 4 plus 5 is 1. So we have 1 to the 5/2 equals 1, and that is true, and we are happy about that. So let's try x equals negative 1. All right, So now I'm going to substitute that in again, parentheses, to make sure that that negative gets included in the square because it's a negative times a negative. Plus 5, and it's really good practice to make sure you put your parentheses around things, because even if you're able to use the calculator, you will need those parentheses so the calculator knows that the negative belongs with the 1 and the negative is not outside or independent of the 1. All right, so here we get 1 minus 5 plus 5 to the 5 halves. 5 minus 5 is 0 plus 1, so that's 1 to the 5 halves equal 1. And this is true as well. So both of my solutions are true. So my solution for this problem is x equals -4 and x equals -1. Right. So let's look at another one. Let's look at x plus 18 to the 3 halves. And we're going to have that equal to x minus 2 cubed. Okay, again, not as complicated because we're just going to take the reciprocal of this. So we're going to raise this to the power of 2/3, which means we're going to raise this guy to the power of 2/3. Right, this becomes 1, so now we're looking at x plus 18 equal to, this one becomes 6/3 because 3 times 2 is 6, 1 times 3 is 3, so that's 6/3. 6/3 is 2, so this is x minus 2 squared. Okay, remember that this is not a distribution because we have the operation of subtraction between the x and the 2, so we cannot just distribute that 2 as if these were 2 factors. These are 2 terms, so we cannot just distribute that 2. Remember what this really means is x minus 2 times x minus 2. And the whole reason I continuously point this out is because this is a common error that I see over and over again where people treat the exponent as if it's a coefficient and they try to distribute that in. Okay, so now we're looking at x plus 18 equals x squared. Again, I'm going to do -2 plus -2, which is -4, -2 times -2, which is +4. We're dealing with a quadratic, so we have to get this into something that's equal to 0, so we can use that zero product property. So subtract x from each side, subtract 18 from each side. And I like how I put plus 18. Don't look at that plus. And I am left with 0 equals x squared minus 5x minus 14. I'm going to factor this. You could use a quadratic formula if you wanted to. So x, 7 and 2, yeah, x plus 2, x minus 7, because a negative needs to be negative. Positive times a negative gives us that negative, and the bigger number has to have the negative to get -5. So in our case, we have x equals 2, -2, +7. Next step, and I know this is tedious, I know it just adds on to the work you just want to be done, but it's always good with these problems to find the extraneous solutions. So x equals -2, we're going to plug in or substitute -2 plus 18 to the 3 halves. Does this really equal -2 minus 2 cubed? All right, -2 plus 18 is going to be 16. So the 3 halves. And this is -2 minus 2 is going to be -4 cubed. Okay, -16. The square root of 16 is 4, so this is going to be 4 cubed. does this actually equal negative 4 cubed? No, because this one's positive and this one's negative. So this is a big X. It does not equal each other. And just so you know, the way I did this is I know this 2 is going to be the square root of 16 cubed. So in my head, I just kind of converted it back into a radical so I can see that the square root of 16 is 4. So X equals negative 2 is an extraneous solution. Let's try the next one, because you actually can have all your solutions being an extraneous solution. I have seen that before in the past. It's not going to be the first nor the last time we will see where both solutions are extraneous solutions. So it's always good to test both of them. We have to do precision, we have to be precise. So we have to make sure that we test everything here. So we have 25 3/2. Is this equal to 5 cubed? Well, remember I said that that half means that's the square root of 25, so we're looking at 5 cubed. And is 5 cubed really equal to 5 cubed? It is. So that is our solution. So the only solution we have in this case is X equals 7. And there we go. All right, so I will see you in the next video. We are done with this one, and I hope you can see the steps for doing this, and I will catch you in the next video.